back, everybody. This is part 2 in our XNA on Visual Basic programming series. In this video we'll be covering how to add sprite fonts to your project, to write text to your game screen, and also we'll cover the very basics of creating a tile map with XNA. It's really similar to how we did it in GDI in the old tutorials, so I'm just going to kind of skim over it and try to get you started here. So let's go ahead and jump on in here. Let's go ahead and click on our form main there and go into your code, and in your Solution Explorer on the right, let's right click on our content directory and add a new item. And you'll see Visual C# items here, and what we're going to do is add this sprite font. I'm going to give it my name, just going to call it SP Font 1 and leave that .sprite font extension on the end. Click add, and now you'll see that it shows up here, and what you get is a sprite font XML file. This will allow you, just by changing this here, you can change the font name to any open type or true type font that you have. So I'm just going to leave the default font here. I've experimented with it a little bit, tried changing to different ones. Some of them worked, some of them didn't work. You just have to play around with that. So let's go ahead and go back into our main form here. I'm going to go down right below our graphics setup, and I'm going to add a little section here. Define resources. Okay, so I'm going to create a public variable called font set as a sprite font, and then I'm going to do another public variable called font position or font pos as a vector2, which will essentially store the position of the font that we create. Okay. What we'll do is go ahead and create a frame counter like we did in the first GDI tutorial. So I'm just going to do FPS counter, and I will dim tsec as integer equals time of day dot second to capture the second, then tticks as integer equals 0. That'll be the number of ticks, and then we will dim max ticks as an integer equals 0. So what we're going to be capturing, just like before, is how many times our loop, our game loop here, cycles every single second. So that's what we'll be doing with that. Let's go ahead and go down to the bottom and create our tick counter sub. So right at the end there, inside the class still, we'll do private sub tick counter. No parameters. And what we'll do is say if tsec equals time of day dot second and is running, make sure our game's still running, equals true, then tticks plus equals 1. So that'll continue to increment. Else, if it's not true, max ticks equals tticks, and tticks equals 0. Reset that, and tsec equals time of day dot second. So we reset the counter each second. Now we can go up and throw that in our game loop. So let's see. Oh, we'd set that up in the last video. So let's just put tick counter here, and that should be ready to go. So before we can draw that, what we need to do, now that we actually have some content here, we have to initialize it just like we did with the rest of our graphics stuff. So in our private function init graphics, what we'll do is down at the bottom of that section, we're going to add a load graphics content section, and what we'll do is create a sub to load the graphics. Okay, these are our actual graphics items like our tile map and things like that, so not to be confused with the graphics devices and things like that that we've initialized previously. What we'll do is we'll drop down below here, since we haven't created this sub yet, and we'll say private sub load GFX, and no parameters. What we'll do here, since we created our font set and font position up here, this is what we'll be initializing here. So we'll say font set equals GC, remember that's our game content variable at the top, dot content dot load. And this is really interesting. This is method or function or whatever it is actually, whoops, I held my shift key too long there, actually has two separate parameters actually separate. So the first one is the asset name. Exactly what it's going to be here is of, and then the type of object that it's going to be. In this case it's a sprite font, and you can close that, and then you open a second set of parameters, and this can be pretty much the friendly name of whatever your object is over here in your Solution Explorer. In this case it's going to be SP Font 1, and I don't even think it's case sensitive, so I mean we could just put lowercase SP Font 1 or uppercase whatever. I'm just going to type it like it is just to be cleaner. Then close that parameter and it should be happy. So this basically associates this resource with this variable, and once you've done that it's usable by your sprite batch and other things. So next up we'll go ahead and just use the sprite batch up here to draw our sprite font. Before we had commented this out because we didn't have anything to draw in the first tutorial, but what we can do is the draw string command on the sprite batch, and we'll use our sprite font font set, and then we'll have our text that we want to draw, and what we'll do is say XNA frames per second space end quote, and we're going to do a C string here to convert this max ticks that we created on our frame counter to a character or a string, and then we need a place to put it, so we can use the vector that we created up above, or you could even just say new vector 2, whoops, vector 2, and then give it the coordinates that you'd like to draw it at. In this case we're just going to draw it to the upper left hand corner of the screen, so I'm just going to do 0 0, and then we have to give it a color. I'm just going to go color.black, and that will hopefully loop through our sprite batch there and draw this string. I'm just going to go ahead and run it here to see if it's working properly. So if I hit that and bring it down here, oh my goodness, that's just insane. We're running at 7,200 frames per second roughly. That's absolutely crazy, but you got to keep in mind we're also not drawing any tiles to the screen. when you start doing the graphics, it's going to bog it down quite a bit, but even then we may be running, you know, close to 4,000 frames per second, which is still absolutely insane. That's plenty to work with, considering that, you know, most games will probably run 60 frames per second or under and comfortably. So I guess we can move on to getting some tiles drawn to the screen. So we'll go ahead and stop that. And what we'll need is a tile set. Need some more content. I have a tileset.png that I'm using from my old GDI project. So I'm just going to drag that and drop it in my content folder, and now you can see it. Now I'll be able to call this in my load graphics sub the same way I did with the sprite font, with one difference. This, your graphics are going to be pulled in as a texture 2D. So what we have to do is go up to the top here, and in our resources, we'll add another resource. We'll say public tile set as texture 2D. And then we have to load it in the load graphics. So we'll come down here again, where we brought in our font set, and we'll add tile set. This time it's going to equal game content dot load of, what's the type? It's a texture 2D. And we'll grab its friendly name in the next parameter, which is just tile set. And there it is, it's ready to be used. So the way that we'll use it is probably, you know, it's going to be really similar to the way we did it in GDI, as I said before. Essentially, we'll be using rectangles to capture a source from the image, and then essentially draw that rectangle to the screen, which in this case is our picture box that we put in there in the first tutorial. And to keep this one simple and fast, I'm not going to be doing all of the, you know, the dynamic get tile source rectangles and all that. I'm just going to create a new rectangle and just do a single grass tile for the sake of time. But what we'll do is get between our SBN and our SBBegin, that's our sprite batch, right where we did our draw string. And this is the place where you're going to load your map, okay? Basically draw your tile map, right? Maybe not load map, maybe draw map. And this will be done almost identically to the way we did it in GDI. So we'll say for x equals 0 to 12. The main difference between this and GDI is that we can safely use a lot more tiles without compromising our performance. Some of you really suffered in GDI, and this is a really nice answer to that. So we'll say for y equals 0 to 9. That's still, you know, less than I could draw if I wanted. So now, you know, what we do is we loop through x and y here, and then draw each rectangle coordinate to the screen from our tile palette, from our tile set. So we'll say sprite batch dot draw, and this time we're drawing from our tile set that we just created. And this will be, you know, just like in GDI, we're going to have our source and destination rectangles, but what we'll do is just say new rectangle. And you could define, like I said, you could define these rectangles as source rectangle, destination rectangle earlier on in the app to make it dynamic. I think those were 32 on this one. We'll find out. And y times 32. Then 32 by 32. So that's our destination rectangle on the form. It's going to draw that grid of tiles. And then here's the source on our tile set. So we'll say rectangle. And I'm just going to grab the top leftmost tile. I'm going to say 0, 0, and the size of the tile, 32 by 32. And this is an interesting parameter here, this color mask that you can throw on it. If you use white, it doesn't tint your tile, but you can actually use it to tint the tile different colors, which is you can add some really intriguing effects to your tile map using that. I'm going to go ahead and stick with the default color.white just for now, and maybe we'll try out one of the other colors too, or something else, just for fun. I'm going to go ahead and run that and kick it off. And okay, so yay, I grabbed pretty much the most boring tile on my tile set. You can see that with the number of tiles that we're painting here, which is 13 by 10 tiles, we're still getting a pretty awesome frame rate in the 5,000s there. So let's go ahead and just for fun, we'll try another source rectangle. This time I'll do 32x by 0y and see what we get. I think that's like flowers or grass. Oh, there you go. Yay, dots. Yeah, let's try 64 for fun. Whoops. Flowers. Alright, so you kind of get the idea. Again, if you want an actual tile map with mountains and trees and things, you're going to want to use something like we did in the GDI tutorial. If you look back at that tutorial, you'll see how to create a sub to get your source rectangles based on your map values that we store to a file. So that's worth checking out. There's really not much else we can do here in this tutorial, so I'll just expand this for fun. 0 by 15, see what happens. Hey, look at that. I mean, I just expanded it by several more tiles, and we're still over 4,000 frames per second. That's just absolutely fantastic. Try different tiles here. That one wasn't very awesome. I'm not even sure these are actually 32. I guess they do appear to be blending okay. So you can kind of see how that works. Oh, let's try this. I'm going to go set it back where we can see our text there. I'm going to grow this to full screen. Oh, it's off the screen. You can't see it. Maybe I can drag my Cam Studio window. I'm sure, I'm running at pretty high resolution here on this huge monitor and still getting 1200 frames per second at full screen. That is fantastic. So just more reasons to switch to XNA, right? Anyway, I hope this has been helpful for getting you started. Most of, pretty much everything we're doing at this point is going to be based upon the GDI tutorials that you saw before, if you did watch those. If not, I recommend you check them out. You can, might get some ideas there. And, I'm sure there'll be revisions in the future, and there's a lot of other things that people have been requesting, and I really got to get on that, but I've been super busy lately. So I hope you can forgive me for the slow rate at which I'm putting these tutorials out. I will catch you all later. Take care and good luck on your projects. Bye-bye.